So whatever things you have learned and you don't get lots of confidence also, that's fine, because it was just for having an idea how the project is developed in the industry in the previous stage. But the modern and latest technology is Spring Boot. So I will highly recommend you. From here, you need to practice properly. You need to have a proper concentration. You need to ask a good questions, any questions if you are having any doubt or confusion, so that it will be with you forever. You know, so Spring Boot is one of the latest and hot technology and the framework, I can say, in the industry right now. Whichever company is working in Java, they are definitely working on the Spring Boot framework. Now, let's try understanding what was the reason it came. Who brings Spring Boot in the industry? How Spring Boot is solving the many problems which industry we are facing. So for this, you need to understand the three terms. First, production ready application. Second, microservices. Third, rapid development. So these three things, you need to have a very clear idea. And if you understand these three things, then you can easily understand Spring Boot is the solution for these three solutions which we are looking for. Let's first talk about the microservices. Before microservices, there is something called monolithic application. What is this monolithic application? So whenever we were developing any project, it was a web application having the lots of module. Take about the example of e-commerce. Under e-commerce, we are having how many modules? We have a cart module, we have a order module, we have a history module, we have a user module, we have a payment module, we have a search module, we have a product module, we have a supplier module, we have a category module. Think about these all modules are sometimes playing independent role. But in the previous stage, when there was no microservices kinds of concept, these all modules were together building one application that's called monolithic application. So it's very, very important for you to understand what is
Yeah.
monolithic application and what is microservices. Because now this day, the moment you will put a Spring Boot inside your resume, the interviewer might ask you, or in fact, they will target you. What is Spring Boot? Why we need Spring Boot? What is microservices? These all things they will ask you. So microservices is nothing but it is a technology term. But most of the things we are going to learn microservices things in the Spring Boot. Microservices will give you some of the design pattern. It's completely a theory, but the technology which we need to learn, it's a Spring Boot only. Okay, so now let's talk about that monolithic application. What was the problems with that? What are the things which we supposed to know about that? Let me open the microservices uh, documentation. Therefore I can talk more about that. Mhm. Now this. Yep. Okay. So let's try understanding the first problem which we have with the monolithic application. So as I told you, there's a e-commerce company, and let's see how many modules they have. They have a product management, order management, inventory management, catalog management, loyalty management. So these are the different modules building one application, which is one of the e-commerce website. It could be related to any kinds of product. But yes, these are the modules are there. And all the modules, we are bind up together as a war file, and this war file is going to deploy into the Tomcat. And to deploy this war file, you need to set up a good amount of infrastructure for this. You must be fed up listening infrastructure. It's not only the Spring MVC. When you are deploying that, there also you need to set an infrastructure. What are the infrastructure we need while deploying? What is the size of your RAM? What is the Linux server configuration? What is the RAM size? What is the hard disk size? What is the processor? Which how many processors are there? These all things are also comes under the infrastructure. Now think about the problem. You are working on this project. It's 99% chance any of this module is having small bugs, which is frequently coming. It is frequently coming. So let's say Amazon is running a sale, but any of their
Mm-hmm.
module is creating a problem when sale is live. Now what this bug cause a issue? Because of that issue, the whole production system is down. Try understanding the business impact.
Right. Right.
Let's
This
say,
is monolithic.
yes, in a monolithic application, let's say your payment module is causing issue. It's not working
Yeah.
as expected. That caused the whole system down. Somewhere you got an exception or error, result is whole application is down. Now this issue is not going to be resolved in very easy way. It's a very tight coupled module. So if you, oh, Sana is here. Let Sana join. Hi Sana, good morning.
Good morning, sir. Sorry for being late.
No problem. I was eagerly waiting for you because this is gonna be a very important class for today.
Yes, yes. Thank you.
Okay, so I'm talking about the monolithic application. What is monolithic application? So a monolithic application is an application which is having the all possible modules together and it is deployed inside one of the web server. So let's talk about this electronic commerce solution. This is one of the e-commerce company having the lots of modules. And let's imagine this monolithic application has a payment module. Payment service is going to be down for some time or it got some issue. Result is whole production application is down. Now user cannot make any order. They cannot go at least and check that. Let me check my order status. No, you cannot do that. If any exception or error occurs inside your web application, that cause the whole application down. So now you have to fix this. For fixing this also, it's not an easy task. It might take a good amount of time, good days. But meanwhile, you have given a date. Amazon sale is live from this date to this date. You found that within that time, you're not able to fix that problem and you have a very big business loss. On the top of that, you have a reputation loss also. So one problem you come to know in a monolithic application, if one application is down, causing the whole system down. Second problem, let's say whenever the requests are coming huge in number, obviously whenever the sale is there, then there is a number of requests increase 4 times, 5 times. Now this application is not capable to handle that because whatever configuration you have set up for your application, whatever Linux server configuration is there, the processor, the RAM, the hard disk, that all are not sufficient to handle the many requests, 4 times extra request. Result, your system start hanging.
Right.
Now what you can do, immediately you have to set up another hardware server which is having the higher configuration, and purchasing a new server is not an easy task. It's a very costly. And again, deploying this application in the new server is another a big problem again. It will take good amount of time. So what you found here? Cost and the scalability issue. Whenever we are moving from Smaller hardware configuration to higher configuration, that's called scaling. We are basically scaling our application in a bigger container so that it will be more powerful to handle the more requests,
Right.
but it's cost effective. So you have to pay a good amount of time amount for this Linux server configuration. And whenever you are adding a hardware, that's called vertical scaling. Remember, there are two kinds of scaling: vertical
Okay.
and horizontal scaling. Vertical scaling is whenever you are adding a new hardware devices to improve the performance of your application. So again, there need to be a time. Time wasting is a major concern. You should not allow to make your application should go for a down. Okay, you cannot go for a horizontal scaling. What is horizontal scaling is saying? Horizontal scaling is saying that right now the Amazon instance is running single. If load increased, automatically another instance of Amazon is start running. Two Amazon server is running. And there is something called router or a load balancer. Load balancer is deciding these requests are coming from this IP address or these requests are from the European country. So route this request to this application, and whichever is from India, route this request to this application. So like this way, what is happening? You are having a two running instance of that Amazon, and based upon that, if you require 2, 3, 4, 5, 9, 10, 1100, you keep on scaling the running instance itself. Rather than adding a hardware, automatically your application will decide, okay, now the load are more than 100, let me create another instance. And these all are automatic. And these all things are well architectured in the cloud. So why people are going for cloud now this day? Because of this horizontal scaling. And this is called horizontal scaling. So you need to have a very clear understanding of vertical scaling and horizontal scaling. Vertical scaling is whenever you are adding a new hardware. Horizontal scaling is whenever your application is automatically creating a new instance. You know, clone. There was some movie I watched in India. It's a Bollywood movie. So whenever the requirement comes, the automatically that guy becomes one more. There was a clone of that person. So that's cloning kinds of things. And when this kinds of architecture is there, then you don't need to bother about it. But why can't we do with the monolithic application? You cannot do this because the application itself is a very big. This can be done once your application is very small in size. But since this is big in size, you cannot go for a horizontal scaling. Okay, let's move ahead. Now, you are using the monolithic application, then you have to decide which technology you are dealing with. You found that Java is the best suitable for my application. So you start developing the each module in Java. There is no chance that one module you are developing in Python and another module you are developing in .NET, another module you are developing in Java. You cannot do that in a single var. It's supposed to be a single technology, single programming language. But think about the scenario. You have a many module, but you come to know, oh my God, search services is very faster in Python. Java is not having that level of technology to make the search more efficient.
Right.
No option there. Even though you know Python is the best choice for search service, you cannot go and change the technology of search services to Python. You are in a Java, your whole code is in Java. So it doesn't matter. Even though performance is not so great in Java, you have to go with search services in Java only. So what you found? Technology bound. You cannot switch for a what I can say heterogeneous technology.
Right.
You have to decide either all in Python, either all in Java, or either all in different technology. Yeah. Okay.
Yeah.
These are the things. Now, what are the other problems? Maintenance. Maintaining a bigger application is a big problem. Anybody is doing any changes, then you have to take that change, and for that change, you have to restart your whole application. So these are the different problem, guys. I'm covering the microservices and the Spring Boot together. So don't think like that. Why this whole discussion is in the Spring Boot? But because you guys have registered for both microservices and Spring Boot, so I'm covering all these things together. So it will be related. If I cover
Okay.
whole Spring Boot separate and microservices separate, then you will be not able to relate it. That's the reason the whole
Right.
microservices is nothing but it's a Spring Boot by technology, and theory wise it's a microservices. So let's move
Okay.
ahead. So fine. So these are the things we have discussed now. Now let's talk about what is the solution for this. In this in this whole architecture, there are many services which is running independently. Think about the product management. What is the work of product management? Create a product and put into the product table. This is the product management. Whenever any CRUD operation is happening related to product, that should impact this product management. But other modules are independent of this product module. They are nothing to do with the product module. Even though all instances are down, product management, if it is a separate service, then it can still create a product and put into the database. Their work will be keep continuing. But how? You have to bring out this particular product management out of this monolithic application. Why can't you create one services, one application only for product management? This guy will create product, put into the database. Now,
Right.
how other application will take this data? Who wants to take this data? The search service, right? All the product which is still available in the e-commerce site, that all is going to be displayed in the website with the help of search service. Now, search service nothing have to do with the product management. This guy just have to go to the database. Try understanding. Product management has pushed that all. Let's imagine this is the common database. Okay, it's not the scenario. Each one is having their own database. There's a different pattern, design pattern, database per services, common database services, saga pattern. Uh, you know, there's lots of pattern in the microservice. So we'll talk about it. But right now, just try understanding. Product management did their work. It's coming to the services, which is database, and database is an independent service. You cannot say that if product management is down, it means the database is also down. No, it cannot be happen.
Mm.
It might be that product management is down, but your database is still alive. So search engine can go and fetch the data from the product service, and still your business is running. Understanding or not? Only people
Right.
cannot add the product or do any CRUD operation on the product. But search engine is still working, search services is still functioning. Now you can think about the each module like this. User on the e-commerce site is not always coming to purchase or buy a new product. Rather than they are also coming to check the status of their product. They are also coming to see the history of their product. They are also coming to change their address. They are also coming to help take a help from the executive. Not always they are coming for buying a product. That's for sure. So why? These all modules now you can think it's independent. Order service can play around. If user is coming only to see what are the order I have given, let's say whole services is down, but your order service is still alive. User is happy. He's thinking, okay, I got what people are saying that Amazon is down, Amazon is down. But when I went to the product order service, I can see that still my order is alive.
Mm.
Let's say
Right.
meanwhile payment service is down, but other modules are alive. Only in the last time that particular customer will face a problem, and you can easily tell them, okay, there is something wrong in the payment service. We will be recovering soon. It. So only the person who is trying to go for a final payment, that users, those set of users will be impacted, not the all users. Getting the point or not?
Yeah.
So
Correct.
the business
So it's
impact.
independent.
Yes, it's independent. All are running as a separate instance. Now, so look at the same monolithic application, how it has been designed into a microservices. So each of the above services playing an independent role here. Since these all are a part of a single project, so definitely they have to interact with each other. Just now I told you the
mm,
product service have to be interacted with the search service, right? Search service have to interact with the other search services. So like this way, with the help of REST API development, you can easily communicate with one services to other services. And that's where the microservices comes in picture. Each independent module becomes one of your services. That is nothing but microservices. Understood?
yeah, yes,
It's very interesting and very, very important.
yeah,
So that is the reason now this day every company wants this microservices architecture. They are trying to come out from the monolithic application. And whatever application they are developing now this day, it is for sure it's a microservices. In fact, whatever monolithic application they hold, the plan is to come out from that and slowly they started the R&D. They are started thinking about the cost, impact, everything. Let's move ahead. Let's talk now some of the advantage. What is this advantage? A small in size. Definitely, it is a small in size. It means you can have a n number of horizontal scaling. You can easily deploy it in any place. Focused. One module is focused only for one particular business things. You don't have to mess up the everything in a single application. If it is a payment service, whatever logic is there only related to payment service. Autonomous. Each microservices should be a autonomous business unit of the entire application. Hence the application becomes more loosely coupled. Obviously, loosely coupled and tight coupled we have talked about in the Spring IOC. You remember, whenever you are modifying a small portion of your code and impact it in the whole application, you found you have to modify the whole application, then it's a tight coupling. But whenever you are adding a certain module, certain changes, but that is not impacting the whole application, that's called loose coupling. So obviously, autonomous is allowing you to have a loose coupling. Technology heterogeneity, I talked about, right? One is Java, another is the Python. But you cannot have that option because all are a part of single var. But here you have a freedom. Each independent modules can have their own set of technology. Microservices developed for search is Python, but whereas product management is Java. That advantage you have. Getting or not?
yes, yeah,
Yeah.
Resilience in property of isolating a software unit. Microservices allows a high level of resilience in the building technology. Yes, this is another advantage. Easy of deployment. Obviously, if it is a very easy, I mean a small in size, then deployment becomes very easy. Now, at the same time, it's having a couple of disadvantages also. And what are the disadvantage? Distributed system. Distributed system in the sense your technology, your software is not specific to a particular region. It can be accessible across the globe. Whoever is having internet, they can access it. So when it's a distributed, you have to make sure that the infrastructure, your data center, the everything have to be very proper, right? A huge set of skilled professionals are required, obviously, right? Now since you have a different technology, initially you had one guy, Java guys, and they are handling the all modules. But now what? You have a different programmers. So different programmers need, you have company have to hire Python developer also, Java developer also, .NET developer also. So cost wise it is definitely high. Getting the point or not?
yeah,
Enterprises readiness, obviously you have to be in a situation always taking new challenges, different technologies every day. Technologies is evolving day by day. Hence, it is quite difficult to make a microservices application. Enterprises ready to compare conventional software development models. So these are the couple of disadvantage, but when it comes to advantage, then it is much more than this disadvantage. So still, other than cost, I, I mean to say that even though it's costly, the each company have to take this model. Got it or not?
correct.
Now, with this, let me stop here and bring the solutions of these problems with some technology. Now, when you start developing a small microservices, Think about initially you were having one Tomcat. You are setting a Linux server, you are setting a Tomcat, you are fitting the all configuration, you are fitting the all database related things, all configuration you are doing one time and your application is running. But now there is a many microservices. For each microservices, you have to set up a Linux server configuration, then Tomcat server configuration, then database server configuration. Oh my God, this is very bad. People will spend half of their life to set up the configuration only. No, 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 no. We don't want this. If this is so, then I will be going with a monolithic application only. It's very tedious
Yes.
job to have a lots of Linux server and lots of things like that. But a Spring framework, people are saying, hold on, hello buddy, I'm here. I have a brilliant solutions for you. People came to Spring framework. They go, what you have? I have seen your configuration. You are very lengthy. You are asking lots of configuration. You are asking a lots of jars. I will not go with you. I'm sorry. Microservices is not possible with the Spring framework. They told, hold a second. I'm not talking about the MVC. I am talking about the Spring Boot. Boot? Everyone starts surprised. Boot? What is Spring Boot? What is Spring Boot? The first demonstration of Spring Boot was saying, we don't have any XML. Wow. We don't have any complex configuration. People start laughing. Are you kidding? Without configuration, you will be running an instance of a web application? Yes. Not possible. Whatever database configuration, at least you should have a database connection. You don't need to give anything. What about Kafka? You don't need to give any configuration for that. At least you must have a Tomcat. No, 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 no. You don't need to install a Tomcat also. People start listening. How it's possible? Going, yes, a Spring Boot has come up with the production ready application. It means that if your development is done, put that jar into your production environment and run as a Java command. That's all. You need just one Java installed in your system and
Oh,
database installed in your system. Rest all this configuration, deployment, installation, everything's going to be taken care by Spring Boot. And congratulations, guys. Microservices was possible because of Spring Boot. For
yeah.
running the any web application, definitely you need web server. The first things Spring Boot people did is they have embedded the Tomcat along with their jar only. So as a part of pom.xml dependency, you're gonna get one Tomcat also coming along with that. Oh my God, you don't need to install a Tomcat. Database related configuration, you don't need to create a bean. The moment you will add a jar of database into your pom.xml file, it's come to your class path and Spring Boot found that class path is having the jar. It means user want to connect to the database. Let me set up the all configurations related to database internally. User is just having ready to use connection. That's all. Kafka, yes, set up the all information related to Kafka. That's all. The configuration I will be taking care how to connect to the Kafka. Amazing. A standalone application mean each services is having a one purpose to serve. There is no mismatch of business unit. Payment service is saying I'm only for payment service. A stand alone. You all die. I don't care, but I'm a payment service. I don't have any problem. I'm still alive. Stand alone. Try understanding. Rapid development. You come to the office and people are saying, hey Nikhil, today I have to write one more service. What service would you want? I want to have one services where I want to count how many sale has been taken. Each order I want
Yeah.
to have a separate count along with the money. What is the total amount we have? Okay, no problem. Go. Tomorrow we will be having this services running. What? Are you kidding? No, I'm not kidding. You came, you created one Spring Boot application, integrated with the payment service, get the payment and integrated with the order, get the order. That's all. Application is
Nice.
running. And this was possible because Spring Boot is saying no need to set up a lots of configuration, no need to write lots of boilerplate code. I will be taking care. You just write your business logic. That's all. Rest all these things I will be having take. I need to take care. And that's where
Yeah.
the Spring Boot becomes very popular now these days, guys. Understood or not? Any
Yes.
question?
Yes.
Any confusion?
Yes.
Yes.
Yeah, it's very, very important to have a wider picture in your mind. You just learn microservices, just learn Spring Boot, you will not understand why. So the first question is coming, why we are learning a Spring Boot? If you clarify these questions by yourself, then rest all the journey will be very easy for you. Now, let's come back to my Spring Boot. So here, the Spring Boot is saying one term, that is just run. Just run in the sense you need to just run it. That's all. And we will be seeing that how it's gonna be possible. So what are the advantage? Easy to understand. Develop a Spring application because the Spring Boot is not asking you to write lots of boilerplate code. You focus on your business logic. So easy to understand and develop. Increase productivity. Obviously, if developer is not spending time to fixing their infrastructure issue, then definitely he will be more productive. He will be completing the stories in a very minimal time. Reduce the development time, and if productivity is increasing, then obviously development time will be less. The Spring Boot is designed in the following goals. What? First point: avoid complex XML configuration. To develop a product ready Spring application in easier way, production ready, I talked about. Reduce the development time, same thing. Offer a easier way to getting started with the application, and it's a very easy to start. You will be surprised to know that how I'm going to develop a Spring Boot application. So right now, I want everybody should open their Eclipse and internet, I mean any browser, and just follow with me. I'm gonna show you
Okay.
one very easy way Spring Boot application running inside your system. I want in this class everybody should have one Spring Boot Hello World application running in their system. How are we gonna go
Okay.
do that? Let's come on that. Then I will be talking about the rest of the things, the internal architecture of Spring Boot later. But let's move to the browser. In the browser, just type startspring.io. Start.spring.io. That's all. Start.spring.io. And just confirm me once you are open this.
Yeah. It's open.
Sana, Vasvi,
Yes.
Vasvi, you joined from mobile or from laptop? Can you open?
Yeah, it's for mobile. Ah, I did it.
Okay, no problem. So then you just focus here. Okay, and later we can practice. Okay.
No, no, no. I already opened in laptop.
Oh, oh, great. So you have,
Yeah.
we all are on the start.spring.io.
Yeah.
Yeah.
Great. So here, guys, look at this. What Spring is saying to you. What project you want? You want a Maven or Gradle project? Because in industry, we have a two kinds of building tool. One is Gradle, another one is the Maven. I will show you the both. Don't worry. So right now we have learned everything in the Maven, and industry is using 90% to steal the Maven. So let it be default. It is asking you language. Which language you want? Java, Kotlin, Groovy. Groovy and Kotlin both are like a Java programming language. Kotlin is now official language of Android. Initially it was Java, but now Android's official language is Kotlin. There is a big story behind this. Oracle has put a case on the Google saying that it is misusing the open source. As per the terms and condition, Google were violating some of the part, and because of that, huge amount has been charged from the Google to
All right.
Oracle, right? So that's the reason Google decided I will be going with my separate programming language called Kotlin. Groovy is also like a Java programming language, but it's more flexible. So do not change anything in this project and language. Spring Boot versions are different versions. Let it be default only. Don't change anything. Then after it is asking you what will be your group name. So just I'm going to give my group name com.nic. You can give anything. Let it be demo, let it be demo, let it be demo, and let it be package name com.nic only. So I just changed the group name. If you don't want to change it, let it be same, no problem at all. And then after here, whether you want jar or var, all the REST services now this day going to be developed as a Java application. We don't want var. Var is required when you are going to have a view like HTML, CSS, and all. A Spring Boot is a completely backend service. So he's saying, I will be not responsible to displaying you the data in the UI. I will just give you data. You write your own Angular services, React services, display the data how you want. But I will give you just data. So let it be jar only. The latest version of Java is 17, but in my system still install 8, so I'm going to select the Java version as 8. So what changes I did? I changed the group name .com.nic and I just